Hey guys, welcome back. This is Harsh, and this video is in continuation to the last video where we were discussing how to find least common ancestor in a binary tree. So once I wrapped up the video, I realized I made a very major mistake. I don't know how many of you have figured that out already, but let's see what the mistake was. So in my least common ancestor problem, I was trying to find the closest common ancestor of two nodes in a tree. Let's say for this example, so for 9 and 11, yeah, the least common ancestor was 2 and we were trying to find 2, and for 10 or 13 it would be 1. But what was the issue with my last approach, or what was the missing link which could break my code? I was trying to find the least common ancestor only when we can say our algo would work only when the two nodes which we are trying to find the common ancestor for are on the same level. It means like if you are trying to find for 5 and 6, it would return 1. If you are trying to find for 12 and 14, it would return 3, or for 11 or 13, it would return 1. But if I try to find with my last algo the common ancestor for 10 and 6, then it would break. Why? Let's see. Why is why that would break? Because what we are doing is we are we are popping both the stack together and then matching the parent. But this would only work if both the childs we are trying to find the parent for are at the same level. As I said in the picture, if they are at different levels, so for the 10, the trace path would be like 1, 2, 5, and 10. And for 6, it would be 1, 3, 6. So when we do the first pop, we remove the 10 and 6 from the stack. Then we are at 5 and here we are at 3 in second stack. Then again we pop 3, we pop 5. Then here in first stack we are at 2, in second stack we are at 1. Then again we pop 1, and in the second stack is empty and the first stack would be at the root node. So and nowhere down the line we are going to find the common ancestor this way, because uh, the path length could be different for one child and it could be different for another child. The reason my code was working because uh, somehow I had entered two childrens which were at the same level. Now let's try to find out if this code works when the children are at different levels in a tree. So for that I would need two childrens. For first I would think I can take one, so its path would be 7, 4, 1. And for second child I would take 10. Its path would be root and then 10. So let's see for 1 and 10. This should break our code, and it should throw an stack exception. See, stack empty because the length of the second node was shorter than the first one. So in this way, we will never be able to find the parent if two nodes are not at the same level. Now, how can we fix that? We can fix that easily. We can fix that easily by, instead of uh, like here we are trying to traverse from the bottom to towards up towards the root, but as I said, the lengths could be different. So what if instead of traversing from the bottom we traverse from the start? In that way we will know uh, when the data for the two stacks are different. Then we'll know the nodes are separating out or branching out, and the last common parent in both the stacks would be the least common ancestor. But we cannot use stack here because stack would always return from the bottom. Instead, how can we fix that? We can fix that easily by replacing a stack with q data structure, because You return the elements inserted in the order, first in, first out, right? Instead of pop, it would be dequeue. Again, dequeue. Now instead for checking if the parents are equal, we know it would be equal. We are just checking when they, as soon as they don't, uh, as soon as the two branches separate out. So we'll know now the next node would be different. Like the two child nodes are now going their own different path. Till this point, it was same. So I don't want to place it here because placing it here, I would be storing the parent one, and which is not the same. So I want the last parent, correct? The last parent. Yeah. So we are fetching the parents, and we just want to break it before we find the parents which are not the same, correct? And here I need to assign some values to the parent, which should be the root node, because at least the root node would be the same in any two childs in a binary tree. So I will do that. And this must be throwing error because it is expecting queue instead of stack. And again, it won't be push, it would be enqueue because we are using queues now instead of stack, correct? And instead of, I should use appropriate name, I would be using q1 and q2. So I will let Visual Studio rename that variable for me, or wherever it is used. By the way, I'm using Visual Studio 2019 and .NET Framework 4.7.2. I think we have made all the appropriate changes, and so as soon as we are popping the parents, and if they are not equal, we break. If they are equal, we continue. Okay, one more thing I just realized, I cannot just use the same parent and also update them. So I will use last parent and current. If they are same, then we'll just update the last parent as parent. I'm just assigning null value to the variables which we would be using to store the current parent. I should just rename it to current parent. Including the root node, because that would be same for any two childs in the tree, correct? And here we would just return the last parent. Yeah, that's it guys. I think that would work fine. And this was the issue of tracing the tree, the path from the bottom instead of tracing it from the root. Let's see if our program would work fine now with the same input. See, it was able to find the root. And I will also check if it works fine for our previous input, which is I guess 4 and 20. Yeah, so, and we can just confirm it once more by passing two childs whose parent is not the root. So we can check for 9 and 20. It should return 10. See? Why is it returning 7? We need to see this now. Yeah, good. It's good. We find as many issues as we can find at once, because then we will be facing any issues in the interview, right guys? So this is the first time I am also solving this problem, and I'm recording it so that you guys can see my thought process behind solving any problem, and how do I approach, and what do I do when I find that my algo is not working. So yeah, it was 7 and 4. Okay, and I was checking for 9 and 20. Yeah, 9 and 20. It should had ideally written me 10. Why did it return me 7? Let's check. So here both the queues are prepared and these are empty. Our function should fill those. 7, 10, 9, right? Our first data 9 and second data was 20. Let's see if the second has 27, 10, 20, correct? So the 10 should be the least common ancestor for uh, these two. And why is it not? Let's see, 9 and 20. So we dequeue this. We, okay, I have this is a typo, and I am dequeuing the first only twice. Here I need to dequeue the second queue as well. Sorry guys, that was my bad. Yeah, it was working fine. There was just typo. Thank you guys, thank you for watching this video, and let me know in case you have any questions or more suggestions, and any better approach I can use to solve the same problem. Okay, and I will also link my GitHub repo link in the comments for the YouTube, and you can check all these solutions and problem which I'm solving on daily basis there, and you can ask me questions regarding that as well. Thank you guys.